Sports. It's something so many Americans and people across the world can all come together and enjoy. Or, in other cases, turn us against each other, but that's besides the point. Something that has become a well-known issue in the 21st century is the prevalence and mishandling of concussions. Far too many times have they gone undiagnosed, possibly resulting in irreversible brain damage that will last for the rest of their lives. According to Brainline.org, there are nearly 3.8 million concussions in professional sports every year, with almost 50% going unreported. Having the ability to detect almost 100% of these concussions would be a major help to both players and medical professionals. But how could we achieve such a seemingly impossible feat? A compact, innovative piece of technology known as a MEMS accelerometer. MEMS accelerometers are being used in helmets to help gauge the amount of force being applied to players when taking hits in body checks. Although the accelerometer was originally developed in the late 1700s, the MEMS accelerometer was first designed in 1979 at Stanford University, according to the University of Ljubljana of Slovenia. Originally used in the automobile industry for airbag technology, MEMS accelerometers have now begun being used in sports for more advanced statistics and data, such as measuring speed and distance traveled. Accelerometers are used in many different applications, such as in medical equipment, navigation systems, and most modern cell phones. Standard accelerometers work by having a micro-machine-proof mass that is suspended between two parallel plates, which vibrates when a force is applied to measure the data. These devices may be the gateway to more advanced safety and protocol systems in our sports.
At North Carolina University, home of world-renowned athletes, they've been designing helmets to help protect our athletes using MEMS sensors, and specialized helmet undergoes simulations. These simulations utilize machines to create human-like attacks to the head, impacting specific parts of the helmet while the MEMS sensors track the data. After over 11,000 simulations conducted, the university gained data on what helmets sustain the harshest blows on violent plays, which helps design companies build a safer helmet. The National Institute of Health is doing similar work, using ADI accelerometers and helmets to see what head areas are most impacted. Their technology is being applied in lacrosse, skiing, and hockey helmets. An upset parent, Karen Lightman, wrote an article about how her daughter was severely concussed from a skiing accident and how MEMS can be used in motion sensors to police intoxicated or dangerous skiers. In the article, she describes a man as doing improper ski movements on a double black diamond. Understandably, she was very upset that his idiocracy resulted in serious injury to her child. She wrote, "I just keep thinking that with MEMS sensors, the next time a similar situation might not result in another concussion." The MEMS motion sensors developed by Zenz and Movia could have alerted the ski rangers of the dangerous skiing and prevented the injury. Before these MEM helmets began being used, the NHL decided to implement spotter staff that would view games in multiple locations throughout the arena to keep an eye out for players showing possible symptoms or signs of concussions. Through providing an improved concussion protocol for athletes, this did not allow for the precise, necessary information required to diagnose most or all concussions.
However, this fault is now being addressed by the company I1 Biometrics, which focuses on the tracking of hits and forces being applied to players, specifically in hockey. Their most popular product, the Shockbox helmet, lets athletic trainers and medical professionals know when a player has experienced a head impact that could result in a possible concussion during a game. MEMS accelerometers are placed within a helmet, which would be connected to an outside system that medical and team staff would both have access to. Whenever a player receives a body check or hit, the accelerometers will vibrate at a certain frequency, measuring the force applied. This allows for the forces being applied to the players to be tracked throughout a game, meaning if the force of a hit was very high, a staff would much have a likelier chance of suspecting and diagnosing a concussion.
With the sports industry constantly growing every year, it is no surprise that the sports technology industry is also growing at a rapid pace. According to marketsandmarkets.com, the sports technology industry is estimated to be worth $31.1 billion by the year 2024, growing 20.63% between 2018 and 2024.
After covering all this information on the concussion problems professional athletes face today in competitive sports, we give MEMS accelerometers helmet technology a 5-star rating because nothing is more important than keeping our athletes safe. With more research being done on the long-term effects of concussions, such as depression, memory loss, and irritability, we must take all the necessary precautions and try our best to prevent these injuries from occurring. Sometimes we get lost in our love for sports and forget that athletes are regular people and have families just like us.